Welcome to my video tutorial. You are watch, stay tuned and make sure that you do not go without anything. Thank you.
When you have something like this, what you simply need to do, you use x is equals to a sine theta. That is what you are using. Then when you are using x is equals to a sine theta, you make sine theta subject of the formula. When you make sine theta subject of the formula, you have sine theta is equals to x over a. That is, you divide both sides by a. So this is our sine theta. And remember, from SOHCAHTOA, from SOHCAHTOA is telling us that we are using opposite over hypotenuse. That is, this is opposite, this is hypotenuse from this right angle triangle. So what this one is basically telling us is that our opposite here is x, which is this. Then our hypotenuse is a. So for us now to get the adjacent here, we are going to use Pythagoras theorem. Then the Pythagoras theorem we are going to use, you will square this. Let's call this place k. It's going to be k squared is equal to a squared minus x squared. So by the time this square now coming over to this place, you will have k is equal to square root of a squared minus x squared. So that is why we have under here square root of a squared minus x squared. So that is, if you see that this one now is giving us this sign. So from the right angle triangle, we're able to deduce this now and fix it in here. Then thereafter, we have been told that we can now make theta here subject of the formula. Then we have sine theta is equals to x over a. What is our theta? Our theta now is going to be what? We take sine inverse of this. By the time we take sine inverse of this, we have sine inverse, that is x over a. That is our theta. Then from this same x is equals to a sine theta, x is equals to a sine theta. What we basically do there is that we will differentiate x with respect to theta. We will differentiate x with respect to theta. By the time we differentiate x with respect to theta, we will have the x, the theta, which will give us. By the time we differentiate sine theta, what do we have? We have cos theta. We have cos theta. Then we make the x here subject of the formula by cross multiplying. By the time we cross multiply, we have our dx is equals to a cos theta, then the theta from this. So what we are looking for now, we've gotten our x to be this, we've gotten our dx to be this, then we've gotten our theta to be this. Then we can now go ahead. So before I clean the board now, let me just write the summary up here. So the summary we have, or by the side here, the summary we have says x is equals to a sine theta, then sine theta is equals to arc sine x over a. Then the x is a cos theta. A cos theta d theta. That is from this proof now. So we limit it here, then we go ahead with this question. By the time we go ahead with this question now, we have something like this. So what this one is simply telling us is that when we are to integrate the x over square root of a squared minus x squared is equals to, we will now integrate our dx. We are no longer writing the x. We are no longer writing the x. What we are writing now, we replace it with this. By the time we replace it with this, we have a cos theta, the theta, then all over. Then what is our a squared minus s squared? What is our a squared minus s squared? Before we get our as minus x squared, we say a squared minus s squared is equals to this a squared. Look at it here. We did that one, but I want to repeat it again. A squared is this, then minus, what is our x? Our x is a sine theta. So we are going to say a sine theta, then you put it in brackets. Okay? By the time we put it in bracket, we have something like this. A squared minus square sine square theta. Then we can factorize for a. By the time we factorize for a, we have something like this: a squared bracket 1 minus sine square theta. Then if you remember from trig identity that we did in SS1, it told us that cos theta plus sine theta is equals to 1. That is square here. Then for us now to get this, take this one to the other side. We have cos square theta equal to 1 minus sine square theta. That is from the trig identity that we did in SS1. Then anywhere you see 1 minus sine square theta, you replace it with cos square theta. So we now have what? A square cos square theta. That is what we have. That is a square minus s square. This is what we have. Then by the time we put this square root on top, we put square root on top like this. When we put square root on top, it means we have to put square root on top of this. When we put square root on top of it, we have what? This one is the same thing as a cos theta, a bracket square, then all raised to power 2. Then remember in mathematics that square, we cancel square roots. When square cancels square root, we have a cos theta. So finally, we will have square root of a square minus s square to be a cos theta. So we are no longer writing a square minus s square. What we are replacing it now is this. So we come and write it here. By the time we write it here, we have something like this. We have a cos theta. That is what we have. Instead of writing this, we have this. Then by the time we proceed, we have something like this. This a, we cancel a. Cos theta, we cancel cos theta. Then we have integrate the theta. Then by the time we integrate the theta, who can tell us what will it be? By the time we integrate only the theta, what is going to be our result? If we integrate the theta, yes, anybody? Just like we integrate the x only, what are we going to get? If we integrate the theta, yes, Ndukwe. Yes, what do we get? Yes, Rosary. Theta. Theta, thank you. So we have theta. And remember, anytime you integrate, you must include your c. You must include your c. Okay? So it's telling us that this particular expression now, we've integrated it to be the x all over square root of a square minus s square is equals to theta plus c. Then from what you proved here, what is our theta? Our theta is sine inverse of x over a. So anywhere you see theta now, what you put there is sine inverse x over a plus c. So we've shown it to be equals to that. Any question at this junction? If you have question, raise up your hands. If you have question, raise up your hands. I have issue, I have problem. Yes? Yes, Onyejelem.
Sir, can I swap the board? Let me see the board.
Can I do what?
Like, I can't see the board.
You can't see the ball. Look at it.
Sir, please spotlight the board.
You can swipe the board now. You don't need to see the you can swipe the board.
Sir, can you start from a square cos theta over a square cos theta?
You mean from here? I'm pointing at where?
No.
A what?
Equals to the theta. Integrate of the theta.
Okay, how to integrate the
yes,
theta?
From there. And from there.
You remember when you integrate the x, what will it give you? It will give you x. Do you understand? The meaning is that let me explain this. Let me explain when you integrate the x. By the time you integrate the x, it's the same thing as when you integrate x raised to power 0, the x. Because anything raised to power 0 is equals to 1. So it is believed that there is 1 here. Okay? So this one now you can rewrite it to be x raised to power 0. So when you have it to be x raised to power 0, then how do we integrate? We integrate by saying x is equals to x raised to power 0 plus 1 all over 0 plus 1. which is the same thing as x raised to power 1 over 1, which is the same thing as x. So that is how, anytime you integrate the anything, it will give you the letter. Okay, so by the time you will integrate the theta, it will give us theta. Then remember, from the proof that we did here, our theta, since we said we are using, since it is a square minus s square, we are using x is equal to sine theta. That was what I gave you in your note. That's what I gave you in your note. Then from here now you can get our theta. By the time you take sine inverse of this, you get our theta to be this. Okay, so which is our theta now is sine inverse of x over a plus c. So I have question now. Let me see your hands up. I am still confused. Raise up your hands. I am Iyomi Ogene. Do you have question? Ogube Charles. Do you have question? 13. Any question? If you have question, raise up your hands. So we have been able to show that what we have here is what we have. Yes. Who is that person? If you have question, raise up your hands. Let me see you. If you have questions, let me see your hands up. Have we understood? Can we continue? If we can continue, wave. If you can continue, wave. Can we continue? Okay, okay. Now, we discovered that they now said we should find this particular question here. That is, they said we should find, we integrate the x all over square root of 3 minus s squared. That we should integrate this. So what do we do? Let me clean this part so that everybody will see it clearly. They said we should integrate the x all over square root of 3 minus s squared. But remember, the question they gave to us is we should show that the x all over square root of a squared minus s squared. So we have to compare this. You can see that what we have here is what we have here. What we have at the numerator, the x, is also what we have at the numerator here, the x. Then let us compare the denominator. If we compare the denominators now, we compare, you compare. By the time you compare, we have something like this. Square root of a squared minus s squared is also the same thing as square root of 3 minus s squared. That is, we are doing comparison now. So from the comparison we are doing, we have something like this. You see that our a squared is 3. Then our s squared here is also our s squared here. So let us compare this a squared is equals to 3. So how do we get a from here? A is what? Who can tell us? Our a will be what? We are comparing the denominator here with this denominator here. So this is what we did here is equals to this. Then s squared here is equals to this s squared. A squared here is equals to this 3. So what is our a? A squared is equal to 3. Yes? Anybody? If you know it. Anayo. A is equals to what?
Root 3.
Sod root 3. Thank you. Sod root 3. Then we now come back to the proof we've already shown here, which says, the proof we've already shown here that says what? Square root of a squared minus s squared is equals to sine inverse x all over. Instead of writing a this time around, we are no longer writing a. What we are writing is sod root 3 plus c. That's what we are writing, plus c. That is the answer. So we have been able to use what we have derived here to solve this question. We have been able to use what we have derived here now, which is this sine inverse of x over a plus c is equals to sine inverse of x over sod root 3 plus c. That's all. I am confused. Raise up your hands. I am confused. Raise up your hands. Enforcer. Any question? Oyibo, any question? Any question before we proceed? Any question? Any question? Okay. So what this one is basically telling us is that sometimes when you have this question, yes. Okay. Okay. No problem. Can you see the board better now? So any question now? Look at the board. Any question? Any question? Okay. So I believe we can proceed. So we are going to look at another example. Another example. From the second example, I want to ask, what are we using? Are we using sine, or we are using cos, or we are using tan? Anybody who can tell us? Are we using sine? Are we using cos, or we are using tan? Which one are we using? Huh? Yes, we have calculator. So what are we using? From this second example that says, show that you integrate square root of a square minus s squared dx is equals to x square root of a square minus s squared all over 2 plus a square over 2 sine inverse x over a plus c. Hence, you find that question there. What are we using cos? Are we using tan? Are we using sine? Yes. Yes, Ndukwe.
I think is tan.
Is what? Tan. You think is what?
X equals to tan theta.
No.
Tan.
You are not using tan. You are not using tan. What you are basically using, you are using sine. I've told you, when you have expression like that, where you have a square minus s square, what you are using is x is equals to a sine theta. That's what you are using. That is what you are using.
Sir, but Mr. Ademola,
Yes.
the negative there won't not affect the sign.
From the question, there is no negative sign in the question. It is when you have negative here. When you have negative here, you have it to be 1 all over square root of a square minus s square is equals, you use x is equals to a cos theta. You use theta when you have negative by the side. Okay? When you have negative sign, you use cos theta. X is equals to a cos theta. Then when you have it to be a square plus s square, maybe over 1, what you are using is x is equals to a tan theta. That is what you are using. Take note. You have those things in your notes. Before now, I believe you people must have gone through the notes that was sent to you. You have all these things in the notes. So what you basically do now, we are still using sine theta. Okay? We are still using sine theta. And remember, from the sine theta we have, that is where we got this right angle triangle from. Then we have x is equal to a sine theta. Our theta is this. Then our dx is this. Okay? So what we need to do, they said we should integrate. We should integrate square root of a square minus s square dx is equals to x square root of a square minus s square all over 2 plus a square all over 2 sine inverse of x over a plus c. So how do we prove this one to be this? So that is exactly what we are going to do now. So let us start with this. Our a square minus s square is what? The x. Our a square minus s square from the previous example we did. Remember I told you our a square, which is a cos theta. A square minus s square is equals to a cos theta. That is what we derived there from the first example that we did. So anywhere you see square root of a square minus s square, what you are writing, you will write a cos theta. So you will come here, you integrate a cos theta. Then what is our dx? Look at our dx here. Our dx is a cos theta d theta. So you put this in bracket, then you have a cos theta again, in bracket, then we have d theta. So that is what we have. By the time we expand this now, we have a square cos square theta, then we have d theta. That is what we have. By the time we expand this. Then after the expansion, we arrived at this particular expression, which means you can bring this a square out, a square, then you say cos square theta d theta. So the question I want to have, we have a square, you integrate cos square theta d theta. How do we replace cos square theta? What are we using? What are we using to replace this cos square theta? What are we using to replace cos square theta? Yes, anybody? What are we using to replace this cos square theta? What are we using to replace this cos square theta? Yes. Anybody? If you have questions, who can answer this question? Cos square theta, what are we using to replace it?
1 minus sin square theta.
No, we are not replacing with trig identity this time around. We are not replacing it with trig identity this time around. Now, I want to show you something. Let us leave this one. No. Now, let us leave this one pending. I want to show you something. I want to recall you back to what you learned in SS2 when we talk of multiple angles under trig identity. Then we gave you a formula on multiple angles. Then the multiple angle says, one of them says, when you have cos A plus B in multiple angles, how do we rewrite this? Cos A plus B will give us cos A, cos B, cos A plus B will give us cos A, cos B, then minus sine A, sine B. This is what will give us. Then by the time we replace this B with A, we have cos A plus A is equals to cos A, cos B, cos A again, minus sine A, sine A. Then this one means cos A square minus sine square A. That is, by the time you add A plus A to give us cos 2A. So that is what we have here. Then let us replace this one now with trig identity, this sine square A. By the time we replace this sine square A, we have this. Is it not 45 minutes? Is it not 45 minutes per period? Why is it 40? That's not what I have in the timetable. Look at this, 9 to 9:45. So this one now will give us cos square A minus bracket 1 minus cos square A. That is our cos 2A. Please, I want you to focus on this board and look at how we derive what you are going to replace this cos square theta here. So this case now we have something like this. cos square A minus 1 plus cos square A. You can see that we have 1 cos square A here, we have 1 cos square A here. It will give us 2 cos square A minus 1. That is what we have. Then, and this is cos 2A, cos 2A. By the time we take this minus 1 to the other side, we are going to achieve cos 2A plus 1. Then is equals to 2 cos square A. You divide both sides by 2. We achieve cos 2A plus 1 all over 2. So this is cos square A. So we are no longer using cos square A. What we are using cos 2A plus 1 all over 2. That is what we are going to replace here. So I've shown you how we arrived at this. So we are going to replace it here. The reason why we can't use 1 minus sine square theta from trig identity is because by the time we substitute this sine square theta will still be there. Square theta will still be there. So that is why we are not using direct trig identity. That is why we are starting from multiple angles. So by the time we replace it now, we are going to achieve this. We achieve this. So which will give us A squared, then we have cos 2A plus 1 all over 2, then the theta. So this A now, we are no longer writing A, we are replacing it with theta. Then we will bring these two out. When we bring these two out, we have it as A squared all over 2. Then we integrate cos 2 theta plus 1 in bracket, we have theta. So we arrived at this. Then we can now split it. By the time we split it now, we achieve this next step. Then the next step we achieve is A squared all over 2. Then we have cos 2 theta plus, the theta, then plus you integrate the theta. Because you use this to multiply this, you have this the theta. Okay? So any question to this point? I have problem, I have issue. Raise up your hands. Before we proceed, let me pause at this particular stage. If you have problem, let me see your hands up. So you can see the reason why we don't use trig identity to substitute for this. What we are using is multiple angles. That is where we got this. Then we replace it here. So any question, raise up your hands. Any question? Any question? Any question? So if there is no question, I believe we can proceed. We have A squared all over 2. Now let us integrate this. If we integrate this, you know that this one now is integration of function of a function. And what is integration of function of a function? Remember, when you are to integrate cos 2 theta, this is function of a function. So what you need to do, you say u is equals to, when you integrate this, you say u is equals to 2 theta. So you differentiate u with respect to the theta, you will have 2. Then you will make the theta subject of the formula. You will have the theta is equals to du all over 2. Then this one now simply means you will integrate cos u. Then our d theta now, you are no longer, the theta is here. This d theta, you are no longer writing it. What you are writing is this, which is du all over 2. We've done this one before. If you go through your notes, that's the second period. Then by the time you integrate this, you have 1 all over 2. When you integrate cos u, you will get sine u. Then what is our sine u? Our sine u is 1 all over 2 sine 2 theta. That is what you have plus c. So instead of writing this now, what you are achieving here, what we will achieve by the time we integrate this, we will have this. We will have this, which is 1 all over 2 sine 2 theta. That's what we achieve. Then by the time we integrate this, by the time we integrate the theta, we achieve theta, then plus c. Then let's put it into brackets. We have something like this. We have something like this. Then when we arrive here, we got 2a squared over 2. Then we have 1 all over 2. Then this sine 2 theta, What do we do to replace sine theta? Then let us go back to that multiple angles again. In the multiple angles where we have sine A, okay, let me clean this part so that you'll be able to see it. In the multiple angles where we have sine A plus B. What we have is sine A cos B plus sine B cos A. Then when you replace B with A, we have sine A plus A is equal to sine A cos A plus sine B sine A cos A. Thereafter, we have this. This is sine A cos A. This is another sine A cos A. It will give us 2 sine A cos A cos A. By the time we add 2 of them together, which we can rewrite as 2 sine theta cos theta. So by the time we write 2 sine theta cos theta, we will now replace this one with bracket 2 sine theta cos theta all over 1, then plus theta plus c, which is this. These 2 now, we cancel these 2 here. Then we have a square all over 2. Then what is our sine theta? Our sine theta that we got here, our sine theta is what? From here, our sine theta is what? Opposite over hypotenuse, that is x over a. So you come here, you write sine theta, we have, okay, we have this, we cancel this. Our sine theta is x over a. Then times, what is our cos theta? Our cos theta from this particular, from this right angle triangle, is adjacent over hypotenuse. Our cos theta is adjacent, which is square root of a square minus s square all over a. So we write it here, square root of a square minus s square all over a. That is what we have here. Then plus theta. Our theta is sine inverse of x over a plus c. This is what we have. So we can see that by the time we multiply it out, let me write it up here. By the time we multiply it out, we have a square all over 2 in bracket. Then we have x a square minus s square all over a square. Then plus sine inverse x over a plus c. This is what we have there. Then we use what we have there to multiply what we have inside the bracket. We use what we have here to multiply what we have inside the bracket. It will give us a square x square root of a square minus s square all over 2a square. Then this one will be plus a square all over 2 sine inverse x over a plus c. So this now we cancel this. So we have what? We have x square root of a square minus s square all over 2 so we have something like this. X square root of a square minus s square all over 2 plus a square all over 2. That is sine inverse x over a plus c. That is what we have there. That is what we have. So, and that's exactly what we have on the board. So when we've arrived at this particular question, and then we are asked to find this. So how do we use it to solve this question that says square root of, that says you integrate square root of 7 minus x squared, then the x. Remember, we have to compare it. You compare. Yes, who's that person? Anaya, what's the question?
I don't understand how the a square cos square theta, how did it change to cos 2 theta over plus 1 over 2?
Which one? How does what?
After you multiplied a cos theta by a cos theta theta, how did it change from a square cos square theta theta?
When I multiply a cos theta times what? A cos theta, right?
Times a cos theta theta, yeah.
That is from the beginning now. A times A. Is it not a square? Cos theta times cos theta. Is it not cos square theta? Just like when we say X times Y.
Theta.
Do you understand now?
Yes, how did the answer change to cos 2 theta?
That is what I said, from multiple angles. From multiple angles. Cos square theta is the same thing as when you say cos 2 theta plus 1 all over 2. It's from multiple angles, and I solved it on the board. That is when you have cos A plus B is equals to cos A cos B minus sine A sine B. Then you replace this one to be A. That is A plus A. Then this will be cos A minus sine A, which will give us cos square A minus sine square A. Then you will now replace this sine square A with 1 minus cos square A. Then you will make this cos 2A here. A plus A is 2A. You will make this 2A. You make this A square here to be subject of the formula. This one will turn to 1 minus cos square A. Then this minus 1, now this plus this, that will give us 2 cos A. Then this minus 1 will cross over here to give us plus 1. Then the coefficient of this, which is 2 cos square A, you use it to divide both sides. That will give you cos 2A plus 1. That is how we arrived at this. Do you understand my point?
Okay.
Yeah.
Yeah.
Thank you for visiting this channel. Click subscribe button.